Okay, and finally we are online, I think. Let's see if I can, if I type some messages, does it go there or not? Hello YouTube and Twitch. And yeah, so both of them have received the messages. Great. So yeah, so we are back, and last time we were trying to we were trying to attempt a challenge, and we did complete that part. We completed the 14th part. Now we are on the 15th part. Let me just log in into my machine and we can start coding right away. Okay. Okay, I hope this is a lot better now. Okay, so now I hope you can see my coding screen, and yeah, we'll start now again. Right, so now we are trying to, yeah, I think we added a to-do statement for creating a struct of all the, like all the senders that we have. So for example, send to master, send to replica, count toward offset or not, and things like that. And I guess there was one more TX we had. Don't remember what was the purpose of it, but it was something useful. Set a sender, and I guess this is the command sender, and it's being used here in the handle command. And if we go to handle command, we can find out where is the sender being used. The sender is being used here. So basically this is just a notification that we have received, or that we have sent the RDB file. Okay, is this the only reason? Yeah, this is the only reason. Right, so in the end we listen to RX at some point, that is here, and that's all. And the other place where we use handle input is in case of master, in which I guess the RX is very important because it tells us what it tells us. It tells us that, okay, to send this node, like the node is connected or not. Okay, just a second. Okay, so I'm back now. So I was just setting up my mic and I had a phone call, that's all. Right, so where were we? We were, yeah, we were looking at like what is the use of this particular sender, like why do we use this sender? Basically this is where to say a new node connected. So basically this would be for node receiver or something like that. It should be called as new node connected or something. Yeah, that's all. New node connected. New node connected. So let's add it to our to do. New node. Yeah, that's all. So now we will just add a lot of signals here. Let's add it in the lib.rs where we would have a lot of such senders, and let's call it signal or something. Struct to signals, and what these signals will contain. These signals will contain. Oh, yeah, sorry for that. This terminal just jumps when I press tab. So yeah, there would be three things. Let's actually go to the to do again. Move it to loop where we have multiple. This is okay. This is a very bad parser, but this is something that we want. Create a struct. Let's copy this and let's move to the place where we want it to be here. Okay, so this is a public new node, which is a sync sender. I think we are using sync sender everywhere, right? So whenever we try to create these kind of senders, we are using sync channel, which creates sync sender and sync receiver. Okay. So this is sync sender, and let's call it empty. Other thing we require is send to master. If we ever receive it, then that's great. Other thing we require is send to replica. Sync sender something. The fourth signal that we want to have is count. Let's see, did replica process it or not? Because there are some commands where it won't be considered processing. So count toward offset. If it is something, because here, like if you look at the example that we have been given, every time we look at it, we always get so there is a ping command that might be counted. Set command is something that will be counted. Even the repl.conf itself will be counted. But what won't be counted? I guess processing the RDB file won't be counted. But that totally depends on our on the result. So yeah, let's see what commands needs to be counted and not. This will also be sync sender. Awesome. So now we have a signal, and now whatever values we have in our main.rs where we are sending something to handle connection, and then we have handle input or something, handle connection, and there is a handle input. So if we go to handle input, what will we see? We'll see a sender. So this should be called signals. Signals. Great. And now we have some signals. And we had sender or something. This should also be called as signal. And basically I wish to create a clone out of this. And this handle command will also accept signals only. This will simplify the whole interface. Oh, there is a Tokyo signal, Unix signal. Yeah, let's use the fourth one. Great. So this will work. And the other thing that we require is cloning them. So let's go to the definition of signals and let's derive clone for this, because since everything is clonable, this should work. Okay, now let's use the type system for our benefit, and it will tell us every time when we are doing something wrong. So there is something called sender unwrap, which is happening at line number 125. So this should be called as signal sender dot new node. This should be called signal dot new node dot send unwrap. So now we can totally clone our signals, and that's great. And let's see what else we need to do is, so lib.rs 270. And this will be called as signals itself. And we should clone this. Always clone it. And let's see, cargo T. An argument to this function are incorrect. That is main.rs 185 and 250. Yeah, I think it's only 185. Now this is called tx. Let's do signals slash new. So let's go to lib.rs and yeah, let's implement new for this guy. Implement signals. And there should be something called as new. Public new. And it should run self. signals. Oh wait, this new function should not always be returning. And all of these can be optional, but I don't want to keep them optional. So I'll pass one signal and all of them can be set depending on the mood of the user. Not on the user, but yeah. So we have a signal and then we need all the receivers in a particular place. So there should be a private receiver and which should tell us was there a new node, was there a send to master, was there a send to replica, and was there a count toward offset. Right, so let's have receivers inside this only so that we don't need to create them. And receiver is receiver of this kind, and we cannot keep it an array. Let's call it new node receiver. So let's start recording a macro where we will copy the line, we'll remove the DWA and we'll call it receiver, and we'll change this to receiver. And this is called receiver. Something is wrong, but I hope it's good. Let's see how good it is. Send to replica receiver, and this will be also this thing, counted offset receiver. Now what is not satisfied? Okay, this whole thing cannot be cloned. Sure, so let's implement clone itself for this guy. And we need a lot of commas here. Okay, impl clone for signals, and we need a new method called as let's implement the default, let's implement the missing members. So this is, it will take something and it will try to clone it, which will take something from the reference and will return a new object. But the receiver, I don't want, this is weird. Sure, I would always have receiver, but I never want to send receiver. How do I separate them? Since sender can be cloned, and once it's cloned it needs to be passed around, but receiver cannot be cloned and it should never be cloned. So once a new is created, I should also have a similar receiver. I think I'll let's call it signal sender. Signal sender. and let's call it signal receiver. Signal receiver. It's a public struct, and sure, every one of them can have some fields in here. And great, now this thing will work. So implement signal sender will generate a new will return signal sender comma signal receiver, and signal receiver is not send, not clone, I mean. So let's see, hashtag derive clone. And I don't want to implement clone again. Since it's already implemented, why should I implement it? So the signal receiver will now be sent to the new function. tx1 comma rx1 is equals to, what should we call it? We should call it mpsc I think we already have it here. mpsc new. Is it only in main.rs where we are creating this thing? Seems like it. Okay, so now once we have these values, we can just have all of them here, and let's name them. Like, we don't really require a good name, we can just call them, I think we can create a macro out of this whole thing, but I really don't know macros much. But yeah, it would be fun exercise to have, fun exercise to do. And then I need to create a signal sender, and this will be called tx1. This will be called tx2, and this will be called tx3. So this is, where is this bracket ending? Is this bracket even ending? Should be ending. Okay, this should be called sender. And the other thing we require is receiver. This will be called signal receiver. Instead of creating this, this is called receiver. I spelled it wrong. Receive, EIVER. Awesome. So let's go there and And now we have everything that we require. So we'll change this to Rx. Well, the order is very important. Cannot mess up the order. This will be called Rx2 and this will be called Rx3. Sure, there should be a better name for all of them. And then we wish to send sender comma receiver as variables, which will be the return value. And instead of sending self, we will be sending this thing. And now there is a missing closing parenthesis. Failed to resolve use of undeclared crate. Sure, this is pretty easy to import it. I hope I'm not using Tokayo anywhere, at least for the sending part. And private type. So signal receiver is sorry, this should be public. And this is awesome. So this should be called as sender / new. This will be called as signal sender. So now everybody will be getting their own new signals. So there is this try receive method which receiver have. So what will it do if there is no such method? Let's actually see. Let's actually go to signal sender new and have a look at receiver, try receiver, like what will it do? Try receive. The animation is a list of possible reasons that try receive could not return data when it's called. So there is a try receiver, this is empty, but the sender have not yet disconnected, so data may yet become available. This channel is sending. This channel is sending half has been disconnected, but there will never be any more data received on it. Great. So there can only be two reasons: empty or disconnected, or we will have some value. But I'm not looking for a value, that's why we did try receive. But I want to do try receive in all of them. So if there is a value, I want to drain it basically. Let's see, is there a drain method available? Let's see here. Rust MPSC. Right, so in here now, if we look at the receiver, we have try receiver where we could have some result and it won't ever block. There's a receive method which will return an error and will always block. So try receive and receive are there. There's a receive timeout which will wait, and receive deadline. So what's the difference between timeline, time mode, and receiver? During an error, the function will always block the content if there is no data available. It's possible for more data to be sent. At least one sender still exists. Once the message is sent, the receiver will wake up and return the message. If the corresponding sender has disconnected, disconnect while this call is blocking. This will call, wake up, and return error to indicate that no more messages can be received on this channel. This function will always block the content if there is no data available. The corresponding sender is disconnected. This will call. This call will wake up and return error. So there is a deadline and there is a timeout. Oh, so deadline is a time deadline. Okay. This will return the messages. The block wait for messages but will never panic. So the iterator will never panic or block the user by waiting for values. So we can use try iter to get all the values, but we don't really care for this. So there is a try receive method. There's something called as try receive, which will return result or try receive error, but we don't need to worry about it, I guess. Wait, what is the size of the channel that we have created? I hope it's only one. Yeah, it's a one size channel. Let's see if we have something called as a drain on this. So there's a method called drain which will block waiting for messages but will never panic. It will return none when the channel has hung up. Yeah, I guess the only method that I'm interested in implementing is called try receive. So let's impl try impl signal receiver. So so all of them should be called this will be called fn. So this is all cancelled and this will be called node received or something like that, which will return boolean which will return two things. It may return two things, that is result of t and some error. And there should be some method called try receive. And there should be a struct called new node, send to master, send to replica, and count toward offset, which will either be boolean or false. Yeah, that seems like a better thing. So public struct to signal, which will be all of these values, but it's just that their type will be different. Okay, weird. So I can just return all these sync sender with something to bool, and I can just remove errors from here. And this is perfect. So there is a method called try receive that we can use, which will take self as a reference, not as a mutable reference, but just as a reference, and it will return signal. Okay, so there is something called as signal. It will be called signal dot self dot try receive, receiver dot try receive dot is okay. So this will be while till weird. This is a lot better. This is a lot better. And this is a lot better. Sure, the names are pretty important. And this should be counter offset receiver. And this will be a public function. Let's do cargo test again. So at 100th line in main.rs, And when we are returning for the method, I can just say rx dot try receive dot new node. Yeah, that's it. If it is a new node, then I'll just add it to the method. Awesome. And here we just do try receive and everything should work as it is. Okay, sure, builds are failing, but I don't really care about the test case for now. And yeah, it's passing. So few improvements that we can make is we can simplify the handle input function. Previously it was always like response, send to master or not, those kind of things. So we can ignore it. There's send to master as a value, and then there is try dot receive. So this whole thing signals. Now this try receive method, I'll just create a default value for the signal, which will be and we'll import this and default. Every time we receive this value, I should call it signals dot response dot try receive, not response. It should be rx dot receive. And now it should be called signals dot send to master. Now this is not required. And now this whole thing can be whack of u8. There's no requirement of a boolean in this world, at least. So no need to return. Let's go to handle command again so that we can fix it. Expected whack of u8 because of return type, and then there's this make error. Awesome. Now things should be pretty awesome. Now we have sent to master, so I can just do signal dot send to master dot send. Great. And I should also unwrap it. If there is some error, then I should be able to use that error to. Where is that dot unwrap? Now I can just go to the send to master, like wherever this is being used. There's a send to replica. To replicas dot. This will be signals dot send to replica dot send dot unwrap. There could be multiple signals in a segment. And now we want to go to result.send to replicas, and this is not required. There is nobody who is using this method, so I can safely delete this. But who is using this method? Great, now we have this signal complete. We can just go to, oh, there is this issue. So arms have incompatible type, which is here. Not really. Where else is the incompatibility? Oh, here it is. Let's see, cargo build. There's a response and then send to replica method. But where is this? This is in main.rs, 100th line, and this is called handle send to replica. So where are we creating this thing? So let's let signals equals to signals default, and let this be mutable value. So every time we are doing this, I'll assign it to signals, which is equals to rx dot try receive, and then this will be signal dot send to replica. Why is that the case? Pretty sure we are reading the value here. Let's see what is the issue now. Okay. And now the final thing, that is counting the bytes. So for this, we can just look into what kind of command. The count is called offset. When a master sends a repl.conf get command to a replica, the replica is expected to respond with repl.conf offset. The returned offset should only include the number of bytes of command processed before receiving this thing. Then let's say replica connects to master and completes the handshake. The master then sends a repl.conf get command. The replica should respond with 0. The return 0 offset since no command have been processed yet before receiving the repl.conf get command. The master then sends again. The replica should respond with this ping command to the replica updates its offset. So ping is the only one, and repl.conf get is the one where we'll be updating the offset. Sure. So let's go to lib.rs. Let's search for ping and let's add a signal. Signal dot count toward offset dot send dot unwrap. Some issue here. And this will be your other case where we need to count toward offset. So this always move to the last position I was typing it. Not sure why. And instead of 0 here, we need to send offset. Let slave is equals to let replica, that's a better word, node let replica is equals to node dot read dot unwrap dot master. So every replica will keep track of these things. And then after that, once we have this, if it's a master, then it will be none. Otherwise, it will be something will exist here. Sure. So now I can just do replica dot offset format. And this will be called replica dot replica dot unwrap dot offset. Now what is the error? Why is it failing? As ref. Great. Now we have cargo build. And every time we go to main.rs and there is a change, if it's master, then sure, but if it is a replica, then whatever this n value is, I just need to add it here. Sure. And if signals dot count toward offset, then in any case will be always now we're not taking ownership of node here, but sure, we'll do node dot write dot unwrap dot mute dot master dot unwrap dot offset plus equals to 1. Not 1, sorry, it will be plus equals to n. What is it saying? And we'll cast the I use h to i64. Now what is the issue again? So this will be called as mute. Wait, this is becoming very difficult to handle, so I'll just create a new node. What's the type? Type is a card. Let replica is equals to node dot master dot unwrap. Replica dot offset. Let's see, cargo build. Replica dot unwrap dot. Cannot borrow as mutable. Clone. Okay, great. So now this is working. There's a weird bug where value assigned to signals is never working, but I am pretty confident with my code, so I'll be adding this thing. What is this about? This is about changing the struct of the code. MPSC, and then we have a lot of things that we have added. Okay, counting offset for ping and repl conf. Get push code crafter. Okay, now I hope that my previous test cases don't fail, because last time they did fail and it was very well. I did learn more about like what was happening, but it was still painful to resolve. Okay, so something failed, I guess. Oh, it failed in line number 11. So as expected, so command to master successfully, and something is not being propagated to replica. So this is pretty easy to find out. We'll just look at our history and see what was not propagated. So somewhere we had sent to replica to be true and we didn't put it to be true. So this is the new node send. This is sent to replica, which is true. And if it is master, it should be sent to replica, otherwise it should be sent to master. So if it is master, then only it should care about doing that. And the other place where we are looking at it is here. And if it is master and there's a signal like send to replica, then only will we try to send these values. And this try receiver should put all of the values to there. There is this count toward offset, and there is a send to master command. Okay, so the other thing that I am still doubtful for is that the implementation of try receiver. And as I expected, the send to master and send to replica are both same. So let's fix it. Lib.rs, go to the top. This will be sent to master. As I thought, it's something that my type system cannot catch. Bug fix. Git push code crafter. Let's see how it goes. Okay, so something else failed. This is now 11th program. And what was the 11th exercise? Don't even remember that. So the 11th exercise was let's see, what was the 11th exercise? Replication 11th stage, single replica propagation. And what happened here? Received okay, sent 3 set commands to master successfully. Replica expecting set foo123 to be propagated. So there is a send to replica command that is still not available yet. Okay, now send to master. send to replica, and count toward offset. Awesome. There is new node receiver, send to master receiver, send to replica receiver, and count toward offset receiver. Sure, the spelling is wrong as usual, but we'll fix it later. So there is a new node tx1, send to master tx1, send to replica tx2, count toward offset tx3. New node, send to master, send to receiver, and count toward offset receiver. So these are okay. So every time we try to do try receive, we will get a new signal where every value will be set depending on whether it is true or not. Let's look for send to replica. And we have this value here. Send to replica before replying to client. Oh, what is this? rx.try receive. We are receiving twice, and that will eat the values that I don't want to. Okay, so anytime we are trying to call try receive twice, it's failing. It should only happen at one time, just after handle input. Sure. Let's see, git add -p, git commit -m, try receive only once. Okay, let's see how it goes. Okay, well, didn't expect this to fail now, but it did fail. Let's see why it failed. Error should not have received a string command, skipping the command. So anytime I'm receiving this, I should not skip it because it will be issue later. Wait, is this the whole input from master and then handling input set, handling input set, and handling input get foo. Is it 1, 2, 3? Set 3 wala. So we have set the 3 value. Get bar, get foo. This is set bar. So yes, we are handling the input. But somewhere this value is not being added. Sure, so some bug as usual. So if it is sent to master, then we'll do it. And then we have again stream.read, we have stream.flush, then we have signals. This should be used at every other place. Great. But we are handling the input. Okay, in which case have I received string command? Listening to master for commands, and then for first time we received plus full resync. Plus is a string command. So in the replication 13, let's see if it is a string command or not. It should not be a string command because there is a plus full resync. What does plus mean? This is plus full resync, and this we should not have received. What do we mean to skip it? Won't skip it. Won't do this. Ignore, sure, we'll do that, but let's go to 13th command. 13th is command processing. In this case, we actually got there is a full resync. So this full resync command should not have been sent to the full resync should be sent to master. And there is a send to master. Okay, so in a case when we ever receive psync, I'll send new node I'll return the new node, and that's all. We return full resync. Okay, so basically I should never have received this command, but something is being set to true. But what is the default implementation? What does it do? So we'll do try receive, okay, is okay, is okay, and is okay. But it never empties itself, right? The sync channel 1, what would happen to it? Let's read about it. I think it never clears itself. Then that will be big problem. The same order it was sent, like asynchronous channel, the receiver will block until a message becomes available. Internal buffer on which messages will be queued, bound specific to the buffer size. When the internal buffer becomes full, future send will block. Note that the buffer size of 0 is valid, in which case this becomes where each send will not return until a receiver is paired with it. The sync sender can be cloned to send, like asynchronous channels. If the receiver is disconnected while trying to send with the sync sender, the send method will return a sync error. Similarly, sync sender is disconnected while trying to receive, method will return receive error. So how can I clear the channel? Like how can I clear the receiver channel? This is nice. Okay, so there is no way for me to clear the internal buffer. Yeah, this is problematic. This I cannot use. Let's see, how do I clear the internal buffer? Drain or something. Does this happen on channel? What do we mean by randomized channel? Basically, it will block until what about size of 0? Will block waiting for buffer to open up. Future sense will block waiting for the buffer to open up. The future send will block waiting for the buffer to open up. Will not return until a receive is paired with it. So it will wait until it gets to the receive. What do you mean by this? Unbuffered channel transfer elements when sender and receiver meet each other. If sender is invoked first, then it is suspended until receive is invoked. If receiver is invoked first, it is suspended until the send is invoked. Both channels takes an optional capacity. The sender will block that whole program until that receiver becomes available. Is it something that I want? Not really, because it's a sync channel. Each send will not return until receive is paired with it. So there is a receive and try receive. With a possible option of pending data on the channel. So if it is empty buffer, then I should empty the buffer. Is not available and it's possible for it to be sent at least once, and at least once a message is sent to the corresponding sender, this receiver will wake up and return that message. Okay, so what I understand is try to receive the data, and for all the values that that is nil, just set it to false or something. So we have to play with these values now, which is very painful to play with. Don't like doing this thing at all. So basically, if it is okay, then I wish to set this to true, and should be good for future use cases. Like I guess I wish to have a new sender every time. Can I do that? I think I can. If there are multiple handle input, then each time when I receive some value, need to ensure that I am handling that part. So let's create it to be a mutable thing. So first time when this is sent, we'll try to receive it, and then we'll assign new tx comma receiver. So this should only be used once, like one of messages. Great. And where else are we using this? This is in the case of replica. And what about master? This should be one of like, let's call this tx. Then the biggest issue is like, how will I solve for the case when they are creating the new? If I go to handle input and if I look for clone, oh, perfect. No need to handle this particular thing. Key.clone, signals.clone, and that's the only place where we are doing this. So in handle command, the whole thing is cloned, which is perfectly okay. git commit -m. Make sure that signals are one of use case. Can I make it one of use case? I think I can, right? Let's not implement clone for it. And this should work. Let's remove clone. And in this case, I'll just send the signals as it is. And what is the issue here? Use of moved value, but where was it moved? Move occurs because signal has type signal which does not implement the copy trait inside of this loop. So inside this loop it can be used multiple times. Okay. So if there are two arrays, like if I got two signals and both of them require different values, then I'll be doomed, right? Because the whole array should be sending different values, right? So first time, so for multiple commands also, I can have multiple signals which might collide. So this is a big problem, right? So basically I should not send vector of vector, I should just send vec of u8 and process rest of the command later, I think. So this is a big bug. Like this handle input, it's quite possible that it doesn't have everything at once. So there is a new response, and then I should always keep doing handling the request until we are over with it. Sure, this seems to be the good way to do it. So handle input should never return vec of u8. It should always return vec of u8 and possibly how much u size it have covered, like of the input buffer. This we always require because, well, cannot do anything for this guy. Now we don't need current index, and now we don't need n as well. And this is the result. Okay, so this is a big issue that we have solved now. Great. Sure. So there is a handle command and I don't need to clone it now. I can just send signals as it is. No need of clone, because clone kind of makes it hard to use. And result comma n. Cargo build. What is the issue? Oh, issue is using the and value. Node needed results now. And don't need n as well. So this time there would always be only one single way to handle the input. And every time the input is being handled, we'll receive a new signal. And now I can safely make signals, not clone. Let's go to handle input implementation. So this is the big issue now. We need to keep doing this until we are over with the result. So let's call it request and I'll do while loop. Sure, there would be a loop. And now we are done with this thing. This is our response. That response comma n is equals to this. Any code following this expression is unreachable since there is no break available in here, but if n is equals to 0, then I wish to break it. And does handle input ever gets a case where the deserialize says that it's empty? So if it is ever empty, then we'll get exception here only. So we should call this basically if request dot length is equals to 0, then I should break out of this loop. And if it is not equal to 0, then I'll try to parse it, and then we'll create new request out of it. Request is equals to new request of and dot dot. And we are done with this. And the other thing that we require is this thing, signals and always send new signals here, and they don't need to be mutable now since it doesn't matter. And when will we ever break out of this loop? We'll break out when this whole stream is processed. And signals is something that we can reuse every time because they never cause us issue. And in the end, if it was ever found out that it's a master, then I should just write it to the, but I wish to put it inside only. Yeah, it doesn't make sense to push it outside. And there is a signal somewhere here. And this is also a loop, and this is also a loop. So there are two loops. I need to name them. How do I label loops? Let's see. Rust label loops. Let's see, label loop label. There's infinite something, and then there is a label name. So let's call it this is our stream loop. Unused label. Wait, this is supposed to return. We can directly use return, right? Why do we need to even label it? Yeah, I guess we can just return here. Is there anything asynchronous happening here? I accepted a new connection and then there is this await. Sure, cannot do that. So it needs to be a break of some stream, which is perfectly okay. Break column stream. This is an unused label, and if I'm ever inside this, if request length is equal to 0, then I will break out of this loop and try to read the new stream.read. I think it should work even if I just break out of some value. Return some stream and then I'll try to receive the messages. And same thing should be done here. Sure, so there would be a mute request, which is equals to request buffer of colon n size. This should be end. There should be a loop again. We should be looking for all the values such that this thing works. We should go and delete the whole and I'll copy this loop thing and we'll paste it here. We'll call it let for response of handle input of ct comma this request. This whole tx thing can be now pushed inside. We can remove all the mutation values. This can be converted to an end, and there will be now a new size after this. Let request be equals to request colon and dot dot. Cannot assign value to twice. Well, I guess I don't need to do that now since we have signals and there is not requirement of an let. no requirement of signals now. And even if signal is being used somewhere, like here, I should break out of it if in any chance if n is equals to 0, if request dot if request dot len is equals to 0, then this means I have completed the code here now, so it should now work in all the cases. Let's see cargo build. Where is this raw EQ? So I should never be importing sender and should never be importing this thing. And this will be called rust. Cargo bay again. And this time it worked. But yeah, I think I'm doing two things at once. I think I can convert that whole thing to an iterator. But that will take some time. Let's see if this thing works. Git commit -m remove clone for the sender and make it one of channel. Git push Codecrafter. Okay, let's see how it goes. Okay, so it failed. Why it failed? So it was expecting commands to be propagated, and I guess this time receiving RDB file, we read 31 bytes. Request is this, response is something. Client received byte plus OKRN, received response value okay. Sending 0 data to replica 0, received okay. Sent 3 set commands to master successfully, and replica was expecting. So sending 0 data to replica 0, sending 0 data to replica 0. Why is it always sending 0 data? Like, what does it mean? sending should be somewhere here where we are sending the data here. So here the data.len is always 0, sadly. And this is the receiver. And who created this receiver? So there is a sync sender and a receiver. And where is this receiver is being used? Okay, where is this sender is being used? I think there is something wrong with this. Okay, this is working fine. So every time when we are creating a new Tokyo spawn, and this is what is this function? This function is called main. I guess this is main only. So we start listening to connections. And then there is a sending commands to replica. Did we ever receive this thing? What is this is master? Sending commands to replica. So my program says sending commands to replica, and it never did send any command to replica. I think. But why did it never send any command to replica? So that is correct. And now the streams we are writing. So once we handle a connection, we should return we got some stream. What is a stream? Oh, streams is a big data source where we'll be putting stream into std. So this will become a sync stream in this case. So in the handle connection now, if I go to handle connection, so anytime I return a stream, like why is there a sum? Like I either return it or I never exit out of this program, right? So this is where I will be returning some kind of stream in case if the whole stream is empty. Wait, I think I should never return if it is 0, because it could mean that so if stream.read returns 0, what does it mean? It can mean two things, right? So buffer specifier was 0 bytes in length and it have reached this thing. So I'll return some stream. That seems to be better. And there is like some request. So if request length is 0, then I should break out of the loop. Basically, I have processed this request and we'll go again with processing new request. Sure. Then whenever we are processing a request, I'll call handle input and I'll change the request now. And there is a column 28 as well. Oh, sure. This seems to be okay. And then we'll return some response. What is the sender then? Okay, and then there is error writing. Once this is done, I'll flush the stream. But flush doesn't mean close, right? And if it was a master, oh, so I should do this first before. No, I think I can do this because this is. So there is a sender. So for each one of these, so every data that we receive, like there should be two kind of senders, right? One is a data sender and other should be the stream sender. The sender.send will send it. Oh, this is the issue. So the request.into will always skip the older request. So I should do this in the end. Once we have decided that we want to be part of this loop and it's not a great. Now I'll do git add -p break break break. One more thing I want to check is, am I doing anything similar here? Most probably not, right? There is this replica called handle replication, and after this replication have been handled, we just look for all the streams, like we get all the data and then we have all these streams. Then one thing I didn't understand is why are we, so this is sending the data and then, well, this is pushing all the replicas. So I guess if I just search for all the replicas, so node.read, there should be all the replicas somewhere here. So there is a streams and there is a streams, and if I go here it should be streams.clone, and if I go here it should be a new vector. And who is using this replica? Nobody is using it, as I thought. This is not being used at all. So even if I don't use it, it should be okay. Sending correct input to the replica. And let's see how it goes. Okay, so still failing at program 13. I think this is the hardest exercise that I have received. Oh, now this time we have a stack trace, so something really bad happened. Most probably I received a string, but why did I receive like a normal string? So handling input full resync, and if we handle this full resync, what would happen? But why is it coming to us? Listening to master for commands and master sent full resync. Okay. Reply from master full resync. What should I do with that reply? Let's read what should be done in case we get full resync from the master. Okay, and afterward there will be an empty RTB transfer, and then sure, master returned full resync, but I don't think it's important for me to process it, so I can skip it as well, and I'll skip it. So in case when we have replicas here, we did 3 commands, right? Now after doing this whole part of values where we have some request buffer, we got something, but it's quite possible that I don't need this, and whatever is after this I should process that. And should I break? Here it doesn't make sense to break, right? At least not here. If n is equals to 0, I'll keep trying the request. So I guess I don't need to break here. So I have a new request, and if request.length is equals to 0, request will always be passed from the request buffer. And then we'll be handling the input here. So we are trying to read some buffer, some values from the n. And once we are out of this loop, we'll read some values again. So in this case, it makes sense to break out of the loop and then try to read again, and then we'll assign the request again. Sure. So let's do git add -p, git commit -m. Don't consider the reply from master. Don't process, basically. Plus full resync from the master. Let's see. Okay, so now we are stuck at an infinite loop. We are always handling empty input. handling, and then there is a handle input, and there is this handling input. So this request, if it is equals to 0, then we break out of the loop, because it doesn't make sense to process a 0 size input. Sure. Oh wait, this Python program from yesterday is still open. Sure. And where did it start from, basically? Okay, I'm not sure where it started, but I can just look at the show logs, and so we got a lot of handling empty input messages. This is a big log file. Sure, can I copy the whole logs? Because I think it just refreshed the buffer and I lose everything that I've been looking at. Maybe I'll just look at, oh, wait for the page. The page got stuck. I guess just a second, I'll just copy the whole value. Okay, so I have copied the values and let's see how it looks like. So this is the whole output. We got stage 1 to pass. Not sure what the stage 1 actually was. Stage 2 was also passed. But in stage 3, it passed. Stage 4 also passed. So I guess this is not a problem with master. Basically, when our program started with replica, this is replication 3, it started failing. Basically, listening to master for commands, and then it went into a loop. Listening to master for commands, and then there is a big loop. And then there is handling input. So basically, in the first case, that whole request buffer that we have, I know that we don't need to process the full racing command, so we can start listening to the values. So if in case this is like empty, which I think it would be, then we'll break it out of loop here. And once we break it out of the loop, we'll reach here, then we'll enter a new loop where we'll read the stream again, and we'll keep waiting to read the stream since the request buffer became empty. We'll keep waiting for it, and if n is not equals to 0, then we'll break, which is good, because once we break out of the loop, we'll reach again here. And okay, this is where the issue is. Sure, so there is an n, which will always be pointing toward, so let's not make it n, let's call it request. And each time there is a read of n, it's just immutable occur here. So this whole request is being handled here at this point. And we don't care about mutable, and let's see who is assigning it. Somewhere here people are assigning it those values. Before doing that, I'll just assign request is equals to request buffer of n. And I need to just borrow it immutably. Great. And now I guess it should work. There's n, but I want to ignore that. So So this is the case where there was not full request. So we'll do request is equals to request of and dot dot again. And now we always have some kind of request to work with. And we should do this at the end of the loop. I have decided that I won't be exiting out of the loop, which is here. So I hope I won't be exiting out of the loop now. If that is the case, I'll exit out of the loop and read a new signal. Otherwise, I'll process that value, work on that signal and everything. Once I'm happy with all the responses, I'll reassign the request and keep working on it. Since this thing is not filled yet, I'll keep doing this. This will be stream.read get def -- staged. So there's a request that I moved up above and I did that at the end. Get commit -m prevent infinite loop get push Codecrafter. And I guess we were not able to handle that infinite loop still. Okay, so why are we not able to handle that infinite loop is because so basically this tells us how much of request buffer we haven't processed. And after we have sent some commands to master, we'll have request buffer and we'll assign a request to it. Like whatever input buffer was not processed, we'll use that. And in the end, it should return so basically in the end there was a reply from master, I guess, plus full resync. So when we got that reply from the master, we read that n and return that n, saying that this is our output. We don't care about rest of the string. So once we're done with that part of the string, we'll take that n and we'll use it here. Once we have the n here, we'll get rest of the input. We are inside a loop now, and let's consider that that was the only request. We'll break it out of the loop. Once we break out of the loop, we'll get one more chance to read the whole input again, which will tell us how much string was read. So if n is equals to 0, then we'll keep trying it. But if n is not equal to 0, then I will assign request to the request buffer of n, and we'll break out of the loop again. So once we break out of the loop again, we should see input from master, and we'll reach here, and we'll keep doing this. But this time request is not 0. So we'll go to handle input again. Inside the handle input, I guess we are calling that function again called handle command, which I guess is creating a big stack of values. Because this handle input calls handle command. Wait, there is no place where this is being called a lot, right? gr. Let's see, replication third exercise. This is the one. This time it's a replica for sure. So if it's a replica, what happened to the log then? Let's refresh and check the logs. I'm thinking the logs would be hues. So this is handling input. Okay, let me take the logs again. Okay, so we got the data again, and yeah, let's see. Let me refresh the page. So this is our latest one. Do they have same number of lines? 44761. No, they're different. So we went to stage 4, stage 5, stage 6, and we started failing at the same place where we are listening to master for commands. So we got plus full resync value here. Okay, one doubt that I have is, in case when we are listening to this whole thing is, we are always printing handling input or something. Handling input is the only thing that is being printed. It's a very tight loop, that's what I can say. So if it is a tight loop where we are not printing input from master, basically this loop itself is not breaking, right? If it was just this loop breaking, then we should have gotten input from master as well. So from the starting we are debugging something different. So there's a loop here and we never break out of this loop inside here. Are we breaking anywhere? No, only this place we are breaking. But this is before we get to the handle input command. So we go to handle input, we see handling input, and then we do result match of input. Wait, so what I removed, I just removed remove comments. Okay, what other error I am facing? Is there a place where is there a loop in here? No, no loop in here. Because in the end I will print like a lot of weird commands like oh wait, can this n ever be 0? So in the case when we ever get unknown, we'll get resp of ignore, and once we get ignore, we just return a vector of values that we that we have processed. But ignore should not be returning one length. This should be returning one length. But this is not always returning 1. This will return, since this is 0, this will return length plus 1. Because we are matching the 0th output, whatever that value is. And we have processed at least that much. Sure. So this I agree. And then we get n here. This n will be 0 or 1, whatever that value is. Let's say it's 1. Then I'll be returning result comma 1. Get commit -m debug infinite loop get push Codecrafter. Okay, so it's still failing, and that's the sad part. I still don't know what is happening. I mean, I do know what's happening, but why is it happening? I mean, even I'm not sure. I'll take a small break then. Okay, I'm back. Let's look at our logs. Let me just go up and just verify. It started happening at replication 3, but it never received replication. Let's look at the logs. So issue was don't process full resync from master. For that, what I did, I just made this n to different n. So basically from here I should look at the whole diff. Right, let's see. So ignore seems okay. Then we removed some comments, and in the handle replication we had n, which was like send commands to master, but instead of having n, like we made it immutable, and we got the value of request here. And since we don't want to send full resync command to master, oh, this will be skipped right now. Because in this send command to master, the n that we send is related to how much request buffer I have read. I think so, but at least let's fix that issue. The n that we have is from reader.read and the command that I'm sending. This is the whole n. Yeah, I guess I can never do this part. This is request buffer. So request buffer is a vector. And this should be what? Now we have a big N here, and I don't wish to use that whole N for anything. And once we have the request here, and we'll flush it and read the new N. So whatever handle input we did, we'll do it here. This is the new N. And inside the handle input, now we would have a command of array or a string. Where is that string? What did I do with that? Hmm. Some comment where don't process this full resync. Sending correct input to replica, where this is the command that we have. What is this thing? Oh, there it is. So start libres lib.rs, and here it is a one. Remove clone from the sender. So binary data is okay, but resp of string should still be there. So this will be called ignoring string command. What is the command? Let's see, string from UTF-8 lossy called string. From UTF-8 lossy. From UTF-8 lossy. This should be dot as ref. And this will be let's see, what do I usually print when I get the data? So there should be request buffer and something. Ignoring the string command. Get push code crafter. I hope it works this time. Yay, great. This time the program worked, but I just wish to see where do we see ignoring string command. Great. Awesome. Now I just need to go to node where they are creating node. Here they are creating, and what is the value that they're putting? Offset -1, right? It should be 0 all the time. And this time it should work. Get commit -m. Setting initial offset to 0. Get push code crafter. Okay, so we messed up. It should be still -1. But where are we setting this offset or using this offset? We're using this offset here in the pacing init. So basically, as soon as the offset is written, we need to, like, as soon as the connection is established, we need to make that offset to +1. And where do we have that offset? This is on the read pipeline. So this should become right to mute. So there is a node now, and I'll do what? I'll do master dot offset plus equals to 1. And this is a new replica most probably. Sure. And then I should yeah, get add. Let's do cargo build first. Adding master offset. Bug fix for -1 offset. Get push. Get push master. Codecrafter. Okay, so I guess the 14th exercise was completed successfully. Let's check. Great. Test still failed. What we need to find out is why is test still failing. But got -1. Wait a second. So placing question mark -1 is okay. And then we have expected argument number 2 to be 0 but got -1. Okay, so most probably it's a clone and I should do as ref. And unwrap will move the value out. This should be called as mute. As deref mute should work better. But it doesn't matter, as mute should suffice for our use case. Now everywhere master dot unwrap we have to do, but this will consume this dot inner into so this unwrap will eat itself, but that I cannot do here now. So I need to do master dot is some master dot so let's increase the value first and then we can work on this part. Master dot map, this is master dot offset should be increased to +1. So this should work now. And the other thing that we need to worry about is the replication ID of master. And this is good enough. And after this point, I can just make it right. And dot as mutable. And I should do mutable dot map. This should be called as m, and we should do m dot offset plus equals to and the other place where we are doing plus equals to n is here. Don't need to do that. Node dot this will be called map map dot offset plus equals to n as I64. And some brackets are not matching correctly. This should be mute and this should be not as mute. Something is wrong, I feel. So master as mutable. Okay, why cannot borrow as mutable? Because sure. Node dot read node dot offset +1. Not wait. Yeah, not cloning the nodes for copying offset. Get push code crafter. Okay, so I think it's still failing. Okay, the issue is that set also is something that needs to be counted. So this is a this will be easy fix. I just need to search for set. Once we have this set, I can say count toward offset and get that -p, get commit -m, consider set to count toward offset. And let's hope it works this time. And finally it passed. Awesome. It took too long to pass, but yeah, let's see. What is this about? We are still working on the instructions for this stage. Okay, thank you. And what else? Test will execute like this. The redis client will then connect to your master and say, wait, it will expect to receive 0 back immediately since no replicas are connected. You can hardcode 0 as a response to the wait command in this stage. We'll get to tracking the number of replicas and responding accordingly in the next stage. Sure. So wait is a new command now, right? Sure, this is pretty easy. I hope. Like since set is there, now we just need to have wait here. I'm not sure about the binary that will be given, and it's a resp integer. Sure, we have resp integers, so let's call this wait 2. Whatever wait we receive, I really don't care about that for now, and we'll do serialize resp comma integer of 0. And let's handling wait command get push. And I hope it works. And awesome, this is also completed. Let's see, what about this? The tester will execute your program as a master like this. It will then start multiple replicas that connect to a server. Each will complete the handshake and expect to receive an empty RDB file. It will then connect to your master as a redis client, not one of the replicas, and send command like this. The response of each command should be encoded as a resp integer, and so this should be like connected replicas. This is also pretty easy to solve because now I know how many replicas I need. That's all. So this should be node dot read dot unwrap dot replicas dot len. And what is the issue now? Cargo B. And this should be now IS as I 64. Sending the list of connected replicas. Get push code crafter. And awesome. The next is also pretty easy. Must wait until either one replica has passed previous commands. Or B, the timeout expires. The wait command should always return the number of replicas that have acknowledged the command even if the timeout expires. The return number of replicas might be lesser than the greater than the expected number as specified in the wait command. Sure, so we need the wait command should return when either or the timeout expires. The wait command should always return the number of replicas that have acknowledged the command even if the timeout expires. The wait command should always return the number of replicas that have acknowledged the command even if the timeout expires. Lesser than the lesser than or greater than the expected number of replicas specified in the wait command. The return number of replicas might be less than or greater than the expected number of replicas. So what if I just wait for that many MS and in the end just return the output? I think I'll do that only. So this will be the number of millisecond, I guess. Yeah, millisecond. And then I wish to like get the values dot into. I hope it parses it to be integer. And then tokayo dot sleep. Let's see what functions do we have for sleep. And is this the last exercise? Yes, it is the last. So I can just make that whole thread sleep, but which I don't think I am inside thread. So I'll just search for Tokayo sleep, because it's never a good idea to use Tokayo and thread together. There is a timeout as well. What does this do? This takes requires a feature to complete before the specified duration has elapsed. If the feature completes before the cannot use this. Interval is there and there is a sleep. If you use it with that, then this does not apply. This type does not implement. It's a create feature time only. Tokayo.sleep. Okay, this is weird. Let's go to cargo toml. It's a full feature. From millis, and this should be millisecond. This should be from the second value. So these are not asynchronous. So I can just you can take the std thread sleep after I'm done sleeping for this. Cargo build. This should be called well, that should be pretty easy to find out whether it's an integer or not. And it's not, it's a string. So I can just parse it. If let milliseconds equals to dot forefront dot binary, and this should be resp dot binary. And milliseconds string dot from UTF-8 string from UTF-8 milliseconds dot unwrap dot parse U64. Let millis equals to this. And then this is what, let's see, cargo build. And there's a parse function which will return let's see what we get. Try dot unwrap. So where else is parse being used? Found cow. And in the end I just need to return whatever the result I got. And let's ignore this part. Okay, let's see what happens with this and git commit -m, adding sleep for the wait command, git push What does this say? It says that must wait either until one reply has processed previous commands or 500 ms have passed. Oh, this is too much amount of time. So basically I should try this 2 times. The wait command should return when either a specified number of replicas have acknowledged the command or the timeout have expired. So this is like a lazy thing, like I need to select on wait and somewhere where we have to read. So there will be like 2 selections that we need to do. Is there something like with timeout and Rust? So there is a wait timeout, a condition variable that we can use. Wait on this condition variable for notification, timing out after a specified duration. The semantic of this function is might not cause the maximum amount of time to be waited for precisely duration. Note that the best effort is made to ensure that time is measured in monotonic clock and not affected by the changes made to the system time. The function is susceptible to spurious wake-ups. That's what I want. Condition variables normally have a boolean predicate associated with them, and the predicate must always be checked each time this function returns to protect against spurious wake-up. Additionally, it is typically desirable for the timeout to not exceed some duration in spite of spurious wakes. Thus, the sleep duration is decremented by the amount slept. Okay, it's already decremented. Alternatively, use the wait timeout while method to wait with the timeout while a predicate is true. Like wait log specified will be reacquired when the function returns regardless of whether the timeout elapsed or not. So now we have a thread where we'll be checking some value. There is a condition variable and we'll be waiting for that conditional variable to be there is this pair command which is like mutex new and condition variable new. And somewhere that condition variable will be that the value has changed. So like there is a global condition variable called notifier, which will notify everyone that okay, something have happened, and this we need to notify when there is a new replica that is added. So replica notification, let's call this. Sure, this seems to be not that hard, at least for now. But we will be returning that value. I just need to periodically check that. And if somebody receives this, then this thing will wake up. It will wait for the timeout. Maybe the value changed and then so it's not necessarily that it have completed that while the timing out after a specified duration. So wait timeout while So we'll always time out in this case. And a condition variable is always associated with some value, some condition, and that condition might be just checking the length of the value. And there is a lock, there is a guard. So there are two things. And this is in std. Wait timeout while. This code seems to be correct and it will work, but need to handle some locks, and I don't really want to have those locks here. It should like notify everyone, and whenever a new thing is added, it will notify the server. Sure. So this will be like a global thing most probably. So let's call this new node notifier. Where is that lazy static? Yeah, there it is. So it's a public static ref. There are two things here now. Notifier, new node notifier. And what is this conver? Okay, what is the type of this value? Let's see. Let's import mutex from the sync mutex, and let's import condition var from the sync. Great. And I guess arc is already there. If it's not there, we'll just import it. And what is this type? It's a and there is a new node notifier here. And now we have new node notifier, and that we will use here. Okay, let's go go to main.rs and then let's search for where we are adding replicas.push sender, and this is a new replica that have been added. This should be called new node notifier dot push. So I just need to clone it here and then just use it. Let do we even need to have new node notifier dot clone? Not if equals to this, which actually have two values, that is lock and cvar. Lock. Okay, what does this? What's the big issue here? This is a struct, is it? R dot clone, and I wish to star this value. What do? They star it and then they take a reference of that value again. So now we have lock, we lock it and then we change some value. That's an empty lock. We don't really need a pending like at all. Let's go to new node notifier. Do we really require it to be mutex? Not really. It just requires this thing. Anyhow, the replica have already some value that it will use. Like there should be node replica list or something. There's a state and the state is, yeah, it's a back of sync sender and there's a RW lock. So I can just go there and this is cvar and this will tell notify all. Because I'm not sure how many threads are connected or which thread is, being writing to that, or how many commands are running in parallelly. So this is great, and this needs to be done before we notify them. Like before we notify them, we need to push to replica. After this is done, we need to know and let's go to some place called lib.rs and let's look for something called as wait. So we'll do this thing, we'll do cvar and we'll do cvar dot wait. This will be wait timeout while cvar dot wait timeout while there is a guard. Why does it requires a guard? Wait on the condition for notification timing out after the semantics of this function are equivalent to wait while, except that the thread will be blocked for roughly no longer than duration. Wait while blocks the current thread until this condition variable receives a notification and provide condition for this function will automatically unlock the mutex specified and block the current thread. This means that any calls to notify one which will happen logically after the mutex is unlocked. Okay, just to wake this thread up. So we need to have lock here, some kind of lock. Great. Not really liking this thing. But sure, there is a lock, and RW lock also have a something good. So let's call this node dot read wait while timeout. And there should be now one more thing called as duration should be what should be the duration? Duration from millis the semantic of this function will accept that the thread will be blocked for roughly no longer than duration. This method should be used for precise timing due to anomalies such as preemption or platform difference that might not cause the. Note that the best effort is made. The return wait timer will indicate if the timeout is known to have elapsed without the condition being met. So basically it will waits on this condition of variable for duration timing out after a specified period. Wait while blocks the current thread until this condition variable receives a notification. the function will automatically unlock. Where is the wait time? Yeah, alternately use a method to wait with a timeout while a predicate is a true. While a predicate is true. This is also a number. Let's call this n. There is a n now called arguments.popFront. And now what we would like to do is there are now n and n here. We'll also do something similar to this for n. And this will become n again. Now this is n. And this should also be okay. This is awesome. And then there's a node.read. Does it necessarily need to have mutex guard? Node.read and cargo build. Expected struck this, but found enum of RW lock guard. Unwrap. And this is also same. It requires a guard, like mutex guard. Is there a general one which doesn't require a guard? There's a mutex guard which is kind of a guard. So this is for guarding some values, right? And what about RW lock? Read guard. And can it be converted to guard, like mutex guard? Unlock the mutex specified represented by guard. And this means that any calls to notify one will happen logically after the mutex is unlocked or candidates to wake this thread up. So this lock thing always needs to be I don't understand, why do we require guard in here? Like, okay, there is a mutex guard, and how is it created? There is a lock method for mutex, and how do we create a dummy mutex? So this whole thing will require that we have the lock before updating the value, so that only one person can ever do that. I think so, but I'm not sure, at least about this, not sure. Mutex of empty tuple I can have, since I don't really care about what is needed here. And then this will be a tuple of values, and this will be called as mutex new with a bracket end. And it's saying there is a spelling mistake which can be fixed here. And now the thing that we require is going to all the places where, okay, it's a big macro. Yeah. Mutex dot lock dot unwrap. Mutex comma cwhere, and this should be called as mutex mutex dot lock dot unwrap, and then this should be unlocked. And then we go back to the place where we were trying to wait for the condition, and this should be called as condition A. And this A is something unknown. What is this A? Nobody cares about this A, but this is wait while. wait timeout while we have a condition f, and f is a it's something that takes a t, but nobody cares about the t. Maybe this is like the length. We don't even need to calculate that. Okay, so I think this should work now. Whatever this value is, it's a condition now. So what is a condition? Condition is that millis, like node dot read dot unwrap dot replicas dot len should be greater than 0. So basically the issue is so how many people will be waiting on this? The number of people who will be waiting on this will be equals to let's say cargo build dot unwrap. So basically this will be logged until the whole condition is true. So blocks the condition and the provided condition is false. So when will this thing become false? Basically as soon as there are more than n values. So if it is less than n, then it is false and it will exit automatically. So suppose n is 0, n is false. But if already 10 people are there, let's say 10 replicas are there and I'm entering 0. 10 is less than 0, no. So we'll exit immediately. And suppose if I enter 10 and only 0 replicas are there, then I'll keep waiting until it becomes false. Sure. So after I'm done waiting for this, I should return this value and the timeout is given. And let's cargo build it. Sure, 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 and sure, sure. Git commit -m. Wait for addition of new replicas. Git push Codecrafter. Let's see how it goes. Okay, so this is still failing, but I guess I have spent too much time now on this, and maybe we'll do it tomorrow. This is a simple problem, I think, and I'm not sure what is the issue. Maybe just what do you call that? Git commit hyphen hyphen allow empty. Rerunning, right? And then git push code crafter. Let's see how it goes. If it doesn't work, then I'll stop the stream and go to sleep. It's quite late. Okay, so it's specifically failing here. Previously it went till replica 3, but this time it only went till replica 1. And yeah, it's failing because of some weird reason. Oh, it tried with replica 2 as well, replica 3 as well, but then it waited for a while and it went to replica 1 again. And I guess at a certain point it was removed from the stream. I think that's what's happening. Stream start clone, and then there is a useless streams if there is an error in writing things from the master, and if there is some error writing, it will just die here. Maybe I should just add removing string, removing replica from the master. Let's use println only. Let's search for sending data to, yeah, I'm not sure what is happening, but yeah, let's consider the stream to be over and let's do this tomorrow again. Okay, thank you, bye bye.